Okay, welcome to the first video of actual examples. The previous I was just talking a lot about what similar shapes mean, and in this one we're going to do an actual question. So, for example, they'll give you two shapes, and they'll say, "Hey, these two shapes are," and the keyword here is mathematically similar, and they might indicate maybe some of the angles are same, so that you know which is which. Sometimes they're triangles, sometimes they're polygons. I don't know, they can be anything, but let's just say I have some triangles here which I'm comparing, and now I know they're mathematically similar. So knowing from my previous video that there's going to be a relationship between the ratios, etc. Now I'm gonna use a method now that's kind of a paint by numbers method, where if you use this method it'll always work. There are different ways of doing this, and I'll make some videos later maybe about the different ways once you have a firm grip of what's going on. But because there can be some confusion with, should I multiply with the scale factor or divide by it, or should I use this reciprocal, and all these questions. I'm going to go with a method that will, I'd say, always work. So in these two shapes, they are asking me information about lengths. So if I look at my little thing here, I'm just going to work with lengths here because they're asking for x, and x is a length. So I need to find the scale factor between these two. So the only way I can find a scale factor is I have to compare something in these two shapes that are the same. And here I have a length of 4, and there I have a length of 12. So because I have those two, what I usually do and what I would suggest is taking the bigger number, which is 12, and dividing by the smaller number, 12 over 4. And then this would be my scale factor. You don't have to write it like scale factor like this, but this is just for my explanation purposes. 12 over 4 will give me 3. Now you don't even have to write the 3. The 12 over 4 is perfect. 3 over 1, whatever you want to do, it's fine. The 12 over 4 works perfectly. But the point I'm trying to make is here you're going to have the big number, and here you're going to have the small number, and this is going to be your scale factor. 12 over 4 is your scale factor. So that's very important to know. So I'm going to use this, and because I'm using lengths, I'm just staying on lengths. I don't have to go to area or volume yet, so that's simple enough. So I'm keeping that 3, and then what I would usually do is I'll say, what did they give me? They gave me an 8, and this 8 is compared to the x. So I'll write that 8. I'll write the 8. And in this case, I'm going from a bigger number, from a smaller shape to a bigger shape. So whenever I go from, let's say, small to big, because they're asking me x here, I know I'm going to use my scale factor of 3, but now I just have to decide whether I'm going to multiply or divide. Now, obviously, you can deduce that, okay, well, 4 times 3 is going to be 12, so 8 times 3 is going to give me x. But how I look at it is just saying, well, I'm going from a small to a big, so therefore I'm going to multiply. Because multiplication, usually, when you think multiplication, you think, oh, things are getting bigger, like 12 times 12, 100 times 50. These numbers are getting bigger. But if I'm going to divide, and hopefully not divide by fractions, but just divide by normal numbers, then numbers they tend to get smaller, like 12 divided by 4 gives me a smaller number, which is 3. So I'm just going to say, okay, well, I put something down that they give me, and I'm going to use my scale factor, and that's going to give me my x. And because I'm going from a big number, a small shape into the big shape, I'm going to multiply. The opposite is also true. So let's say I had 30 here, and they wanted y. Then I would start with my 30. I'll write down the 30. Let's just do that in a different color. Let's say blue. So I'll write down the 30, and I'll write down my scale factor. And I know that's going to obviously give me y. And now I just have to decide, am I going from a big shape to a small shape? So, well, that's what's happening here, because obviously the 12 is bigger than the 4. So I'm going from a big shape to a small shape, and that means I have to divide. So 8 times 3 in this case is 24, which we didn't really do. And then 30 divided by 3 is going to be 10. So x is 24 and y is 10. Now, a different way of looking at it, and I'm just going to mention it here now. just because I want to. But you can stop the video if this was good enough. We'll do another. Oh wait, don't stop the video. I already said you should. Okay, never mind. We'll do in the next video. We'll do area. But just as an interesting fact, this is if you really like math, or maybe this method might be easier for you. If I took 4 over 12, I could write 4 over 12. In this case, I'm taking the smaller number over the bigger number. And I could just say 8 over x is the same as 8 over x because they are the same. So this is another way of doing it, getting an equation like that, or even swapping those around, saying 12 over 4 is going to be the same as x over 8. And in this way, you can cross multiply, you can work this out and multiply or divide, etc. But you're going to get to the same answer. So in this method, maybe you say, well, 4 times x is 4x, and that would be equal to 8 times 4. So sorry, 8 times 12 is, oh no, I forgot. Can you believe I'm forgetting 8 times 12? Too much pressure for me. 96, and 96 divided by 4 is going to be 24, just like we got there. And in this case, you can do the same. Obviously, you'll see the same works out. So 12 times 8 is going to give me that, and 4 times x is going to give me that. Or you can just work this out as a fraction and say, well, the 12 over 4 is going to be 3, and I'm going to multiply with the 8 on both sides, and then I get x, which is also 24. Okay, so these are different ways of looking at it, but once we go to area and volume, sometimes these things confuse students, I've found. So I'm just mentioning it here. In the next video, we'll take a look at area.